Okay, we've got some notes here on linear relationships, and I wanted to run through these with you, just kind of describing what we've got here. And so a linear relationship is a relationship between two variables that when we turn that relationship into a graph, it makes a straight line. And there are lots of linear relationships. Basically anything that you graph that turns into a single straight line is going to be a linear relationship. In 7th grade, you focused on a special kind of linear relationships called proportional relationships. Now, a proportional relationship is a linear relationship, but it is unique and special in that it has to pass through the origin. It must pass through the point 0, 0 for that linear relationship to be proportional. Okay, go ahead and pause here if you'd like to write some of these things down. I'm going to scroll up. So looking at an example, a couple examples of both linear and proportional and only linear. We have linear and proportional on the left. Those two blue lines are straight lines, or as close as I could get. And they both pass through the origin. And so just to call it out really quickly, the origin is this point right here in the middle where the x and y axes cross. So those lines both pass through the origin and are a straight line, so they are proportional. On the right, these relationships are only linear because, as you can see, they are straight lines, but they do not pass through the origin. And so those lines would still be linear, but not proportional. Again, I will pause here and let you write things down if you need to, and I'm going to move on. Okay, we have linear and proportional versus only linear, and I've got quite a lot to add to this. I just wanted to stop at this point and have a conversation about what I've already got here with you. And so let's take a look at both of these that I'm highlighting green. Y equals kx and y equals kx plus c. You would have seen y equals kx in 7th grade. And what that means is there's a relationship between y and x, and that number k would have been some kind of, or that value k would have been some kind of number, like y equals 3x. That would be an example of an equation that follows the rule y equals kx. And you'll see in the second, you'll see on the right that we have, so y equals kx here, and we have y equals kx plus c over there. That plus, capital C, means plus a constant, and that constant can be any number other than 0. And so if it was to be 0, that would match with this one, and it would still be proportional because the 0 would not move the line around on the graph. It would still pass through the origin. So again, those first two, these two rows right here are kind of ambiguous and weird because there's just a bunch of letters there. Let's take an opportunity to do this with some actual numbers in there. And so a proportional relationship on the left, like y equals 3x, I can make that relationship not proportional by adding a constant to the end. And so that plus 4 would actually take the line away from the origin and move it up 4 units on a graph. A couple more examples of proportional versus linear. We could have something like negative 2/3 x. That would be proportional because it would pass through the origin. And I can change it to make it not proportional by adding any number to the end. Now that relationship is no longer proportional, it is only linear. And one more. Let's take a look at this one. We will have y equals negative 17x. That is proportional because it does not have anything added to the end. I can make it only linear by doing something like this, adding just a 1 to the end. So again, you can kind of see that on the left, if I was to sort of vertically go down the right side of all these things that have an x there, there is either not a number there or there is a plus 0. So nothing is being added. Alternatively, if I go down the right side of these equations over here, every one of them has something being added to the end. And so again, as soon as we add something that is not 0 to the end, it becomes only linear and no longer proportional.